Hi everybody! In today's tutorial we will have a close look at how to integrate and work with 3D models in your virtual tours. The new feature available in 3D Vista that dramatically expands your creative possibilities. For that we created this demo, which I recommend you have a look at yourself first. We will use it in this video to showcase and explain most of the new features, so you know how to create and use them. So after this tutorial, you'll be able to create these kinds of views with animations between them, and thus to visualize different aspects of your object. You'll know how to add and modify the lights, even to switch between different lights. You can also have different variations of the 3D model and show one or another by means of this configurator here, for instance. And you can allow the user to directly interact with the animations so that they can play the animations that we created in a controlled way and make the object come to life. Right, so let's dive right into it. First of all, it's important to prep your 3D model in whichever 3D program you're using. We use and recommend Blender. It would even be useful to organize your structure of objects in such a way that you group the common things so that you don't have too many elements or meshes that will later appear in the object list inside VT Pro. And then once you have your model ready and prepared, you export it in GLB or GLTF format. You can do this directly inside Blender or using other programs or even an online converter to convert your model from one format to another. Quick heads up here. We have noticed that in some cases we had certain features which were not exported well from the normal version of Blender for some reason, but they did work fine when exporting from the latest version, the beta, currently 3.3. So just keep that in mind in case some things don't work, then maybe just try and export them from the beta. So let's start. This is 3D Vista VT Pro, and we create as usual a new project in which we are going to import the 3D model that we already created. As you can see, we have two options, and in this case we are going to use the Orbital mode, which allows us to have our car in the center and the camera always rotating around it. Here we have our model, as we said, in GLB or GLTF format. We open it, and now we already have it in the media list of our tour. Double-click to open it, and now we can start to visualize it. First, let's create the thumbnail. This part we're going to leave as it is, since we're not going to make measurements on the car, and that's a feature explained in the tutorial of the flyover. What we are going to do is check the Optimize model. This will drastically improve the performance, while you can hardly appreciate the loss of quality in the details. And we're going to leave the textures as they are without compressing, since I already did this process manually, reducing the quality of the images when importing them in the materials of the model. So they are already compressed. And the rest we're going to leave as it is, so let's proceed to the next tab, Camera. Here we are going to define all the camera settings, add views, and create sequences. First of all, we'll mark this current view as the initial point, so that even if we move the camera around, we can always instantly recover this view that we like. We're going to leave the field of vision at 75. In terms of the advanced options, the speed of rotation and translations are fine the way they are set by default. The initial zoom value as well. The minimum value. If we zoom in, you see this is the limit, the closest we can get right now. But maybe in some cases we would like to be able to zoom in more. So in order to do that, we would have to reduce a little bit this value to get to this zoom level and be able to observe all the details. And the same happens with the maximum value. This perhaps is too exaggerated. Maybe we don't want the user to be able to see the car from so far away. So we could limit it a little bit, for example, up to this point here, so that now the user can play from this zoom level to this one. We can also limit the yaw, for example, if we don't want to show a part of the back of the car. Or the pitch, for instance, if we don't want to show the bottom of the car, because maybe in our model we haven't worked on that part. Well, then we could lower the maximum instead of 90 to go reducing it, so that even if I rotate now and I try to pull and see the bottom part, the camera doesn't allow me to get underneath the car. Remember also that we have this option, which lets us limit how far the camera can move. So now we've defined the point up to which the camera can move. And in this way, we leave our car well configured. Actually, upon changing the camera limits, it altered our initial view a little bit, so we have to set it again. Next, we have this panel here where we can start creating the views that we like of the car. For example, this one. When you click here, a view is generated with the camera position we currently have in the viewer. Let's create a second view. For instance, like this. And of the interior. And another one of the wheels. You can see that every view I create gets stored and listed right here so that I can return to those views at any time. And we'll show you in a minute how you can add them to different buttons for direct access in the final tour as well. We can, of course, also edit the views' names here. And if we wanted to improve an already established view a little bit, we can simply adjust the camera in the viewer to where we like it and then click here. In this way, this new camera position is set. And now the interesting part is if we go to the skin and create a few buttons, I'll actually import a skin which I already have prepared. So now we can go ahead and associate each of these buttons with a specific view of the ones we just established. For example, for overview, we're going to add the action 3D model, open 3D model. We select our model, and here among the options we are going to choose show view. And from the list of views we have created, we're going to select the first one, overview. Here we can define the duration of the transition, so how long it takes to go from whichever point of view that the user is currently in to that new view that we have chosen. We'll leave it at 1 second. And then we do the same thing for the rest of the buttons. What I'm going to do here is take this action and copy it with Ctrl+C. Then I select my next button here and paste the action with Ctrl+V. And here I'm simply going to go in and select, instead of the view overview, the view specifications. The rest can stay the same. Paste. Select the interior view, and we do that for all of the buttons. Let's look at it in the preview. So as we click on each of our buttons, it goes to the associated view. It's also worth mentioning that we have a panel here for the global view settings, meaning we can change the duration and type of inertia up here once, and it gets applied to all of our views here, so that whenever any of these views gets opened, it takes this value by default, and you don't need to go one by one defining it. And last but not least, we have our sequences. These allow us to create defined paths from one view to another, adjusting their configuration, and with which we can create those cinematic sequences like the one we've seen in the intro of this tour. But we will explain that at the end of the tutorial once we've gone through all of these tabs. So let's proceed to the next one. Right, so this is the Environment tab where we are going to define the background and surroundings of our model. First, let's add a floor or platform on which our model will rest. So we take this box, and as you can see, it creates this floor, which we should start by lowering its height so that it'll sit right underneath our wheels. Let's also adjust the size of the floor, make it a tiny bit smaller, but we leave the color and opacity of the platform as is. You can see on our platform that the shadows that the car projects are already visible through the lights that are set by default. As an alternative to this floor created here in VT Pro, you could also import your model in such a way that it already comes with the platform, and in that case it would already come with baked shadows projected as we want, so that we would have more precise control over those shadows, reflection effects on the floor, etc., and other types of effects that we could not do with these controls here. Then here we have our options to define the background. The most basic would be to add a flat color, but in our case we're going to opt for a background image. So we click here, and I already have a series of background images prepared, one for each view of the car. So I'm going to select them all, and now they all appear here in the list, and I can make one at a time visible. So as you can see, I can only have one turned on at a time. We're going to enable this one as the initial one, but we will make it so that when the user clicks on each of the buttons we had before, it'll change the background image. To do this, I'm going to select this one, for example, and we're going to give it the action 3D model, change environment. We select our model, which includes the background images we just added. As you can see here, we can also change the type of floor, the background color, but what we want to do is to change the background. So I select that and enable this image and not any other, to make it visible upon entering the view through the button, no matter where the user came from before. Again, let's copy this action, select the next button, and paste it with Ctrl V. And now we simply select this image instead of the first one. And the same thing for the remaining buttons as well. Now we go back to the Environment tab, and you can see that we also have the option to add a panorama as a background instead of just an image. This way, the background will actually rotate with the camera instead of remaining fixed as it does with the normal background images. And the other characteristic when we import as a panorama as opposed to an image is that we will be able to use that panorama as a reflection map. So I could either enable it and make it visible here, even though in this case the image I imported is not actually a panorama, it is a photo, but it will be useful for us here to see the reflections anyway. Or leaving the background image we had before, leaving that visible and enabling this option enabled as reflection. And as you can see, especially in this area here where we see how parts of that panorama image are being reflected, it is even generating additional lighting on top of the lights we already have in our model. See? If I turn it on and off, you'll be able to see the difference. Depending on the image you choose and whether it has a lot of contrast and especially the level of reflection of the textures that you have added to your 3D model to begin with, these reflections will be more or less intense. Either way, they do tend to give more realism to our objects. In any case, for this example, we have used a much more subdued image so that it does not light the car up so much, although in the darker versions with less light, those reflections are quite a bit more intense. Now let's have a look at the lights. And for the purpose of explaining this, let's first delete these two lights that appear by default, so you better understand how this works. For example, you see that even though we don't have any lights at the moment, the car is still lit, so you can still see it. This is because, as I said, the reflection map is already generating a certain amount of light. You see if I turn it off now, the car is completely dark, right? So with this off, let's see how the lights work. When creating lights, we have two types: ambient lights that give a general light all around, and directional or orbital lights that come from a specific point out there somewhere in the infinite and have a direction that they shine in. We are going to create an ambient light, and as you can see, it illuminates the whole scene globally without the light coming from a specific direction, right? This can be useful to provide a certain level of general illumination to everything, and then combine it with maybe a more realistic directional orbit light. And we can change the color of this light, for instance, to give it a warmer, more yellowish tone, or whatever you want. More blue. All right, I'm going to delete it again, and now we are going to create a directional, an orbit light. As you can see, these already have many more options. The first one would be to have the light fixed to the target or to the camera. In target mode, the direction will always point to the same part of the object, and in camera mode, the direction is relative to the camera. As you can see, if we move the camera, the light on the card changes. Let's leave this one though, which is the most usual. We can change the color, the intensity, and of course the direction. We can change the direction using these parameters, yaw and pitch. We could put it completely vertical and then turn it a little bit. Or we can also use this option right here and click on a point somewhere on the surface of the object so that the light will shine directly towards that area in that direction. You see? If we click here on the side, the light comes from here. If we click here on the top, the light will come from above. So you can do that, and then subsequently we'll adjust it a little bit with the controls. Next, we have the property of projecting or not shadows. If we deactivate it, we see that there are no shadows projected on the platform, on the floor. And if we activate it, there are. We can widen a little bit their radius. And we also have this very interesting box that would project shadows on the object itself, not just on the floor. So now if we go back, these controls also affect, if you see here, for example, the shadow that projects here on the object itself. That's a series of adjustments to make the shadows more defined or more diffused. Tolerance is especially for when we have objects that are animated, for the surface to which the shadow will be applied. We leave it at the maximum. Let's change the direction a little bit. With the bias, you can retouch it a little bit and thus sometimes avoid some artifacts that may occur in the shadow. And map size is the quality of that shadow. The greater the number, the higher the resolution of your shadows, but of course it will also consume more resources and be a heavier file. So what we recommend is that you play around with these adjustments and try to reduce this number as much as possible, and especially also reduce the overall number of lights, and very important, the number of lights that project shadow. The fact that they project shadow, and especially project shadows on the object, will require processing a much larger amount of information, which could negatively affect the performance, and the movements or transitions may not be as fluid. Ideally, if you can, create the minimum number of lights possible, or even import your 3D model with the lights already baked in the textures of the model. That way, unless you need dynamic lights that move with the animation of the object, this would consume much less resources. If you do that, you'd have the option of marking this box up here so that the lights in VT Pro would no longer affect the model, and it would only pick up the light and shadows that the model itself already brings. In our case, as we have not imported it that way, well, it doesn't work. But it could be useful in cases where you have a lot of geometry in the scene and you don't want all that geometry to cast shadows or to be affected by those lights. And finally, like we said earlier, very important to play with the combination of our lights with the lights of our reflection maps. In fact, now that we have the reflections, we can see that the lights we just created may just be a little bit too strong. See? That's better. In our sample tour, we have used the following combination of lights. This main light with these values, and this is actually the only one that casts shadows. Then we have this second light, which is a little bit of a filling light for a certain area. This one that fills another area with light. And then we have a night light with the intensity 0, which we only use in some determined cases. These values can be changed by means of actions in the tour, and we can even determine the duration of these changes so as to generate transitions between one set of values and another. Let's have a look at that with one of the buttons that we have prepared, which would be this one. And the idea here is that when clicked, it'll turn off all the lights, turn on the night light that we've prepared, and also change the reflection map. Because if you remember from earlier, we said that the image we used as reflection map actually generated a lot of light itself. So instead, we'd use an image that generates no or much less light. Let's start with the action of turning off all the lights. So we go here, 3D model, lights, and here we have the list of all of our lights. We select light 1, and since we want to change its intensity, we tick intensity and set it to 0. And as I just mentioned, we can edit the duration of this transition. We leave that at 1 second. And now we copy this action and paste it, because now we want to do the same thing with light 2. And the same for light 3. And for the night light. We will set it to 0.2. That means that this light, which had 0 intensity before, will now turn on to a value of 0.2. And now last but not least, about the reflection map image, let's go to the subtab environment and import an image that's almost black to use as a reflection map in which there's almost nothing to see. But we leave the original image active in the normal state. Let's also import a new background image, a darker one, this one. And then we go back to our skin, to our button, and add the action 3D model, change environment, and we go to background. And we activate both the reflection map of this black image and change the background to this image. Let's hit preview to see it. So we click our button, and as you can see, all lights turn off, only the night light is on, and the reflection map image is another one which has no illumination whatsoever. In terms of these images, we recommend you use very optimized images with low resolution, as you will hardly notice the loss of quality, but the performance will be much better. Let's move on to the next part. Alright, let's now have a look at the Objects tab, which will allow us to manage changes between different elements of the car, such as colors or types of wheels. So if we go here in the program to the Objects tab, we will see a list of the different elements that make up our 3D model. It does not matter whether in our 3D program we had some objects hidden. Here they will all appear as visible. And with this icon we can show or hide the different elements. So what this is about is that in our 3D program we go and duplicate those elements and make the necessary changes to those duplicates, for example a different color, another type of wheels, or another type of upholstery. Then we re-import and we'll find all these new elements here in our list. Before I further explain this, I do wanted to quickly mention that we could do something similar in the Variants tab. In here we could create different versions with different textures, and this is important, only textures, so no changes in the actual objects or their geometry. So we could, for example, create 3 variants of the car, one with white bodywork and brown seats, one with black bodywork and white seats, and another one with any other combination. So we'd prepare this in our 3D program, export it, and then it would all appear here in this list of variants, so that we could visualize variant 1 or variant 2 or variant 3. The limitation here is that we cannot make combinations. We could not combine one type of bodywork from one variant and another type of upholstery from a different variant. And that is why in our case we decided to do it the other way, by duplicating objects and changing their texture. This in turn has the disadvantage that it implies duplicating parts of the geometry of the model, so that the final generated file will be heavier and will have more geometry because it will have some of the polygons duplicated, which in some projects could be a disadvantage. So depending on the tour, you could choose one method or another. Although this one, variance, we will explain more in depth in another tutorial. As I was saying, now what we do is go to our 3D program and we go duplicating the parts of geometry that we want versions of. For example, the body in red, in black, and in white, etc. Or the upholstery, where we also have prepared duplicates with the texture changed of each of the upholsteries of this area. Or the different types of wheels. Once we have everything created, we export it again and be mindful not to modify the names of any old elements that we had already exported into VT Pro before, as importing them again into VT Pro could give errors. Right, so back in our project in VT Pro, now what we want to do is replace this old model with the new one that contains the newly created elements. So instead of adding media, we go to the subtab Settings. And from this blue icon here, we will import the new model so as to replace the old one, but maintaining all the settings that we have already configured. So I select this one, which is the new one. It loads. And as I said before, it can happen that even though in your 3D program you have left a certain combination of elements hidden and others visible, here the program is going to import them all as visible, and in some cases they will overlap, showing some on top of others, which is why we see this red door here. We go back to the Objects tab and see here that all the new versions of the elements we have created appear now in our list. From here we can hide or show them. We see the different versions of the upholstery. The lights on are also objects that we show or hide. The wheels. And that way we would be leaving our model ready and prepared. We also added our own floor with baked shadows. However, we don't see it yet because we first have to remove this floor that we inserted from VT Pro earlier. And now, as you can see, we have a floor with a softer shadow, and that's the one we imported from the 3D program. See? If I disable and switch it on and off, we can see the floor that we have created and imported. Now let's go to the skin to see how we can create and offer interactivity with these newly imported elements. First, we make our button panel visible. We select the first button, the one that'll turn the car white, and we are going to add the action 3D model and show hide objects. We select our model, and here in the list, we select this one, which would be the white bodywork, and we make that visible. And the rest of the bodywork we mark as invisible. And then we're also going to look for the doors, and we are going to make these first ones visible, which are the white ones, and the rest all invisible. Click Done. And we do the same for the black color. So we set this first one, which is the white color, to hide. We show this one and the rest hidden. And the same for the rest of the colors. We then proceed in the same way and add the actions to the different types of upholstery, types of wheels, or to the button which turns on and off the lights. So basically, they're all actions of showing or hiding objects. And with that, we already have this part done and resolved. Let's do a preview. And by clicking on the buttons, indeed, we are changing the colors of the bodywork and the doors, and also of the seats, okay? So that is how we would achieve this configurator or options part. For the animations, the first thing would be to go to our 3D program and generate all the necessary animations. We would have to animate each element separately, so the white door, the green door, the black door, and even the windows of the white door, the windows of the green door, etc., to have them as independent animations and then be able to activate one or the other in VT Pro. This way we generate each animation independently and not on the same timeline. When exporting, it is important to mark that the animations also be exported so that in VT Pro we can then recover the whole list of animations. Let's have a look. So back in VT Pro, again, we go to the Settings tab, click on the blue icon and replace the file with the new one that contains the animations. Open. Everything remains the same. And if we go to the Animations tab now, we can see all the independent animations of each object listed here. If I select one, we can play the animation. See the window go up. If I click on these ones, however, we don't see anything because the objects that contain these animations are currently hidden. They're the ones of the other colors. With these icons, we could turn on the autoplay for the animations that we want so that these automatically play by default. Or we could mark sequential autoplay so that when we start viewing this media, it'll automatically go one by one, reproducing all the animations automatically. When this one finished playing, it'll move on to the next one and then to the next, etc., etc. And here we also have some more general options for autoplay. For instance, to play in loop. So when the last animation was played, it'll go back and play the first one again. The show control slide option, which makes the playback line appear. This one, which allows the user to pause and resume the animation through a play button, like the ones we have in videos. Or when the animations reach their last frame, they stop and stay there. But for our demo tour, we're going to leave everything unmarked because we're going to control all these animations from the buttons of the skin and the hotspots that we will put in a minute. Maybe you already noticed that I have only created the animation of opening the doors or raising the windows. I have not created the reverse animation to close the doors, and that is because in VT Pro, later through the actions, you will see that we have the option to play the animation and to play the animation in reverse. And that obviously saves us a lot of time by not having to manually generate each reverse animation of closing doors by hand in the 3D program. I'll show you what I mean. Go to the skin, to the Open Doors button, and we add the action animation. We leave this on play, and now we mark all animations related to doors. And in our case, we're also going to mark this option so that when the animation finished playing, it'll stay on the last frame, so on the door completely open, for instance. Hit done. And now we are going to select the other button, the inverse of this, so the Close Doors button, and we add the same action. We mark all doors. We also mark that it stays on the final frame, but now we are going to set it to play in reverse. So that is how easy it is to have the animation of the doors closing. Hit done, and we leave all our buttons as they initially were. And we do the same for the window button. We select all our window animations. We mark the last frame option, hit done, and the same for the inverse button. We mark this and especially this. Leave our skin buttons as they were. In order to, when we click this Open Doors button, have it swap out for the opposite, so the Close Doors button and vice versa, we would also have to add a Show Hide action to those buttons so they act in a toggle manner. We do that with show hide components. We do the same but the other way around for the other button. And let's do a preview and test our animations. Click on open doors, they open. And if we click on close, they close and they stay in the last frame position. In the same way, let's raise windows and lower windows. So as you can see, it is very easy to manage everything related to animations in VT Pro once they've been created. Now let's have a look at how to add hotspots on our model and thus be able to trigger the actions of opening doors, turning on lights, changing wheels, etc., not only from the buttons in our skin, but directly by clicking on hotspots that are placed on the actual car. We click on this button to add an image hotspot. We select the image we want, and now we can add and place it on any part of the surface of our model. Let's put it here, for example. Once added, we can go in and make it a little bit bigger. If we want to reposition it, for example, to a more central area, we can click Set Location and click to where we want to place it so that it'll move there, maintaining all the rest of the settings. We could leave it like this so that it is always visible, but it may be interesting to mark this so that it is only visible when it is not covered by any other element. And as it is sometimes cut off by the model's own geometry, we go and increase the distance so as to separate it a little more from the model. And once the hotspot is in place, we simply go ahead and add the action it should trigger. In this case, it would be to show the panel with the color options that we have created in the skin. So we select Show and mark this component. And that's it. Let's create another one for the action of opening the door. Let's put it here, for example. Separate it a bit. And for this one, we're going to select the action 3D model, animation. We select all the doors. And hit done. Now we basically have the same thing that we did for the door icon in the skin, but now through a hotspot. Let's relocate it a bit, put it here a little further back. And now we need the same hotspot, but with the action of closing the door once it is open. Therefore, let's first rename this one so we don't mix things up. Then we copy and paste it to duplicate it, and this one will be the one to close the doors. And in terms of the action, we're just going to reverse the animation of this action. With that, we would have the button to close the doors. Now we're going to make this one invisible by default so that only the open doors hotspot is visible. And to this one, we're going to add the action Show Hide Hotspot. And we set it to show, so to show as soon as it is being clicked, the closed doors hotspot. And another action that when being clicked will hide the open doors hotspot icon. Now we're going to copy and paste these two actions, paste them to this hotspot, and simply reverse the actions. This way we achieve a kind of toggle, which in reality are two different hotspots. We would do the exact same thing for the hotspot of the windows and for the lights. And that would be all for the hotspots. Let's do a preview. And here we have our hotspots. If we click them, we see that it works. The open and close doors hotspot Same thing, the first one opens, and if we click on it now, it closes the doors. That's how we would proceed with all of them. In this part, we will explain how we made this first click to start screen, and most importantly, how we created this sequence of animations, which is not a video, but the model itself, seen in a predetermined order of views and animations in which the lights are also animated in such a way that we create these cinematographic effects. We will explain this very briefly though, without going into too much detail, since all of this is explained in more detail in the flyover tutorial. First, we have a very simple loading screen with an APNG image that creates this small animation, and we have that on ready. Then, in the skin, we have this first completely black container, which serves to cover the 3D model that we will have loading behind. Inside this container, we have the click to start button that we have hidden at start because we will show it through this action at start, so that it is displayed gradually after the delay and with the duration we want. The advantage of having this button is that it obliges the visitor to click and thus allows the browser to play audio. Otherwise, you'd have the typical system message asking for permission. Then we also have our texts ready and prepared. Those will appear bit by bit during the sequences. Basically, what we did here is when the visitor clicks on the click to start button, we make this black component disappear to reveal the 3D model behind it. And at the same time, we open the 3D model to play the sequence intro. Let's go and have a look at that sequence. That would be this one with these views. The thing is that as we have the lights off, we see very little. As you can see, I have the scene already prepared for the start. So in the first sequence, we have this first shot, and in terms of lighting, we have an action which slowly illuminates at the same time as it changes direction to generate this animation. You see? So in here, you can play around with the values and do tests. And once you're happy with it, you write down the values so that now, in the sequences, you can generate the actions with those values. So our sequence shows this first view, and that view also triggers the action of playing the audio track in which we have all of our sounds. And this one of the lights that has the intensity marked to increase from what it was to 0.2, and also the yaw to go from here to here, which is what we did in the little test just now, and a little bit of the pitch as well. And all this for a duration of 4 seconds, so that in these 4 seconds the intensity goes up and the light creates this path changing direction and thus generating the animation. While at the same time we go from view 1 to view 2 throughout these 3.8 seconds. So the step from here to here, okay? Then also in this view 2 we begin to create a fade effect. We showed the skip intro button. And we prepare the lights for the following shot, this one of the wheels. In the same manner, through such actions, we make the texts appear, play sounds, etc. And that way we achieve these cinematic sequences. You could have everything in one single sequence, or, as we see here, split it up and pass from this sequence to this one where we have the initial view of our model, and also using actions we bring back the lights to their normal state and make all skin elements and buttons appear to prepare the tour for navigation. And this separation of the sequences allows us to give the skip intro button the action to directly open this sequence. If you need, as was our case, you can also create other similar sequences, but with the variations necessary to optimize the layout for mobiles, so that later in the skin you can make this button play the desktop sequence, and in the mobile version, this button would open, as you can see, the mobile sequence. And with this, we finish our tutorial about 3D in orbital mode. The rest of our tour are elements of the skin, like these, with basic actions of showing or hiding elements. I'm sure you've seen that once we prepared our model in the 3D program, managing it and making it come alive in VT Pro is quite straightforward. It's just a matter of managing a few actions to control animations, lights, cameras, objects, etc. And that will allow you to create unique interactive experiences to familiarize, learn, and make your audience fall in love with whatever you're presenting, whether it's in sales, marketing, product visualizations, industrial applications, or even teaching. The use cases are unlimited. So we encourage you to use this new media type, start incorporating 3D objects into your virtual tours, even if you are not an expert in 3D modeling. There are so many resources available out there, and you can purchase a multitude of objects at low prices, or even pages that offer free models. Or start creating your own models using photogrammetry simply by taking pictures from different positions. We hope that this tutorial has been useful, and we'll see you in future tutorials.